Hello students, welcome to EPG Pathshala. So today I will discuss on the chapter 13 under the EPG Pathshala module name Information Retrieval. So my name is Anindo Basu and I work as a librarian in Maharani Kasheshwari College, Shambazar, Kolkata. So this chapter is about the statistical methods in information retrieval system. So from the previous chapter's knowledge, you can now understand that why information retrieval we need, what are the objectives of information retrieval, and different methods you have already known from the previous chapters. So now I will basically discuss about the statistical methods which are required for any information retrieval system. So information retrieval system is basically a three-step process. First one is the document indexing and storage, second the query formulation, and third one is mapping the query with the documents which are relevant and present to the user. So every information retrieval system involves these three steps. Whatever maybe the search engine or searching facilities are there within a web or within a website, whatever, all this follows a basic steps, that is different methods of retrieval of the documents and give it to the user. So previously the librarians first understood the need of systematic storage of documents, represent them with some scheme so that retrieval of the document is very easy. So that's why different cataloging rules, classification schemes, those came up and later implemented within library or public library or very specific or technical library, whatever. Now the searching is, we must say that searching is an art. So the searching involves a systematic process. The librarians first realized the necessity of searching in a systematic manner. But the approach of searching are different. So that's why post-coordinate indexing system and pre-coordinate indexing system that came into being. In pre-coordinate indexing system, the index terms are very fixed and those are being incorporated with the help of any subject heading. But the necessity of searching of the index terms on the fly became necessary in the future. That's why post-coordinate indexing system came into picture, and that basically gave the modern approach of information retrieval. Okay, so until 1990s, information retrieval was the subject for the librarians and the information experts only. But early in 1990s, the evolution of World Wide Web, that is WWW, changed the whole arena or the aspect of the subject totally, and that this subject, that information retrieval, became a hotbed of research for the computer scientists, statisticians, mathematicians, and many algorithms came up to address different type of informations so that user can get the relevant information with an ease. So every search engine has some pre-processing steps for the retrieval of information. So first step is the collection of documents. The documents may be of different type, may be structured, it may be unstructured, and different file formats are there to contain the information. And now the heterogeneity of information is tremendous, and different file formats are coming, suppose for graphics. So maybe it may be a PNG file, it may be a BMP file or JPEG file for the image file. It may be text format, the text format may be doc file, text file, and other formats are there. So maybe the photograph also, online portals are there which actually store different type of video as well as audio files. So the information retrieval system should index those files, store them, and retrieve whenever the user is giving the query, and that query should be matched along with the documents index, and that should be represented to the user. So that is the background of any search engine. So just I will tell about some pre-processing steps. First one is the choice of index terms. So I should explain this in this way, like suppose a sentence is there. Suppose I am going to Hyderabad for a video shooting. Now if you can understand the expression of meaning from the sentence, you can also understand that few words are there which are actually semantically rich, and few words are there which are in syntactic type. So like that, suppose I am going to Hyderabad for a video recording. So going is semantically rich. To Hyderabad, it's a place name, it's semantically rich because it carries the expression of the meaning. And video recording, obviously that is the objective. So apart from that, I am, then to, these are actually semantic types. Semantic types means they are syntactically needed for the goodness of the grammatical expression. So that's why only those words are coined which are semantically rich, which actually carries the expression of the meaning that is intended, and other words are actually being removed from the documents. These words are basically stop words. Stop words are like those are mainly articles, preposition, conjunctions, because they are actually needed for syntactic analysis. So any indexing scheme or any information retrieval system, they basically they remove the stop words, and only the semantically rich in terms are coined. So these are basically called index terms. So after choosing those index terms, a term document matrix is created. So it's a row and column wise matrix. The columns represent the document IDs, that means that the documents which have been indexed, and row wise it represents the terms, that means the terms which are actually present in the documents. So each cell of the matrix carries the occurrence of the particular term in a document. Suppose term 1 has occurrence in document 1, document 2 and document 3, and suppose there are 9 documents which have been indexed. So the corresponding cell value for the term T1 along with the document 1, document 2, document 3 will be 1, and rest for the documents the occurrence is 0, so that is represented at 0, and the documents which carries that particular index term, suppose for T1, those have occurrence of 1. So likewise the term document matrix is created. After creating the term document matrix, a posting list is created. A posting list is nothing but a list where the occurrence of a particular term in which documents are mapped. It's just a list. Suppose term 1 has an occurrence in, suppose, document number 1, document number 15 and document number 200. So the posting list will be created as term T1. A pointer will be created. The pointer points to the document ID, that is document 1, document 15 and document 200. It is just a posting list. So keep in mind that the posting list is the heart and soul of any kind of search engine. For a retrieval purpose, every search engine must create a posting list. Now, the different statistical methods or mathematical methods, whatever it may be, those methods basically work on this posting list. Okay, so now I will explain the Boolean methods, vector space method and probabilistic method of information retrieval. I will concentrate only on these three models because these are foundationals, and keep in mind that there are many sophisticated algorithms which work at the background of search engine, but every sophisticated method are basically based on these three foundational models. So the first model I will explain is on the Boolean retrieval model. So it is based on Boolean logic. So Boolean logic was discovered by George Boole, and the Boolean mathematics or Boolean logic is the heart of any computer system for the encoding of characters or special characters or whatever. The same logic is represented for the retrieval purpose. The Boolean logic are based on only two terms or the two way of representation, that is 0 and 1. 0 means the lower value, 1 means the upper value. So Boolean logic is basically on set theory where different operators are there like AND operator, OR operator and NOT operator. AND operator is basically disjunctive type, OR operator is conjunctive type, and NOT operator is for negation purpose. So suppose two Boolean expression is there, suppose 1 plus 0. So if I put into the operator, so the output will be like this. If 1 and 0 are there, so that will be 0. If 1 and OR is there, so the output will be 1. If not 1 is there, that becomes 0, means that if 0 is there, NOT operation on that particular expression will give the opposite result. That means if not 0 is there, it will be 1. If not 1 is there, that will be 0. So we all know this because the Boolean algebra is needed for any kind of computer system. Now, if we make a term documents based on the documents and the index terms, so I have explained what is the term document matrix. So here I have taken one example of term document matrix, and I have explained the way of Boolean retrieval works based on this example. Students, have a look at the screen. Now you can see the term document matrix where the columns represent the document IDs and the rows represent the index terms. So just I am again explaining what is term document matrix for the understanding purpose. Suppose term T1 is present in document D2, document D3, document D6 and document D8. So the cell value for the corresponding term T1 is 1, and the rest of the document IDs have 0 because the term has not occurred in that particular document. Likewise, suppose for the term T2, and it has occurred in document D2, D3, D4 and D6, and also D7 and D9. Other document IDs will get a 0 value because the term is not present. So after constructing the whole term document matrix, I am giving a query. Suppose the query is find those documents where term T1 and T2 are present but T8 is absent. So the query can be translated into the Boolean notation, that is T1 AND operator T2, then again AND operator, not T8. Not T8 is required because the query is given in such a way that I have to retrieve some documents where term T8 is basically absent. So that's why not operator is needed. So the query can be simplified by the Boolean operators present in the query form. Now you should keep in mind that Boolean operation here is bitwise and not is a complement of the term expression. Now you can see the particular Boolean expression of the term T1 and the term T2, also the term T8. So the Boolean expression for the term T1 is 0 1 1 0 0 1 0 1 0. Boolean expression for the term T2 is 0 1 1 1 0 1 1 0 1, and for the term T8 the Boolean expression is 0 0 1 0 0 1 0 0 0. Now first we will negate the Boolean expression for the term T8. That means I will just do the complement for the Boolean expression for the term T8. So after doing the NOT operation for the term T8, it becomes 1 1 0 1 1 0 1 1 1, and then I am doing the binary AND operation bitwise. So after doing the binary AND operation, it becomes 0 1 and the rest are 0. That means that document ID number 2, that is the document 2, is the only document where the term T1 and T2 are present but T8 is basically absent. So for the retrieval purpose from this Boolean logic, I am retrieving the document D2 as it is satisfying our query. So that's why in that way the Boolean logic works as a retrieval model for any kind of information retrieval system. Though it is the most weak form of retrieval model, still many web portals, many information systems, they incorporate the Boolean logic for the retrieval purpose of their documents, which are at their disposal. So now that's the end of the Boolean model for the information retrieval. So I will just explain what are the advantages and disadvantages for the Boolean model. First one, the advantage is it is very easy to codify, and the AND operations are the Boolean operations are very easy to implement. But the disadvantages are a Boolean search criteria is based on the binary decision criteria executed with bitwise binary operation, which eradicates the possibility of including relevance factor. It also cannot segregate the searched result with its degree of relevance. Second disadvantage is, although Boolean model has precise pragmatic formalism and formulation, but it cannot understand the natural semantics present among the terms. So the finding related concepts or resources from such space is out of the scope. Natural language based query from the user sometimes are very difficult to transform into Boolean type structured query. So these two are the main disadvantages of Boolean based information retrieval model. Okay, and that was the end of the Boolean model of the information retrieval system. So it is the logic and the operation behind the first model is very straightforward, and one can easily understand if one can refer to the example and the operation, so they can easily understand. So I'll come to the next part of the chapter, that is the vector space model. So vector space model is a little bit advanced from the previous one because the Boolean weights are very limiting and very much straightforward. Here the documents in vector space model was first devised by Salton. So he gave the scheme based on the vector algebra, where each term in a document or a query is represented as a vector or a t-dimensional vector. That means that each word in a document are basically represented as a vector, and that is also applicable for the query. If you look at the slide, you can get a glance of the expression, vector expression for the document that is represented as dj, where suppose the t number of words are there in that particular document, and those are represented as t-dimensional vector. Suppose for a query there are n number of words in that particular query, so the query is represented as n-dimensional vector that are basically all the words present in the query. Each expression for dimension here indicates to a separate term. If a term occurs in the document, its value in the vector is non-zero. The definition of term depends on the application. The query terms may be single words, keywords, or a string of words, that is also known as phrase. The dimensionality of the vector is the number of words in the vocabulary, that is the distinct words in the corpus, and it is dependent on the term chosen by the query. Several vector operations can be used to evaluate the relevance of the documents along with the queries. So to understand the vector space model, we have some prerequisite knowledge of vector algebra. So any vector expression, whenever that comes to a coordinate system, we basically represent the vector with its mod value and the angle that is incident on either on x-axis or y-axis. So each query and document are put into the coordinate system, and then we measure the angle that is present between the document vector and the query vector. So relevance rankings of documents in a keyword search can be calculated using the assumption of document similarities theory by comparing the deviation of angles between each document vector and the original query vector, where the query is represented as the same kind of vector as the documents. Vector space model proposes to evaluate the degree of similarity of the document dj with respect to the query q as a correlation between the vector dj and query q. The correlation can be quantified by the cosine angle between the two vectors. The similarity function can be represented as similarity between dj and q. So at the numerator part, it is the dot product of the vector dj and q. At the numerator part, it is the cross product between the mod value of the vector dj and the vector q. In practice, cosine of the angle between the vector is calculated with the following equation, that is cos theta is equal to the dot product of the document vector dj and the query vector q upon the mod value of the vector dj multiplied by the mod value of the vector q. Now the mod value of dj is that is also called the norm value of the vector dj, and the norm vector of the norm of the vector q can be calculated as q is equal to root over of q square summation of I to n, and after doing the summation we do the square root of it. As all the vectors under consideration by this model are element wise non-negative, the cosine value, so the range of cosine value may be from 0 to 1. If the cosine value is 0, that means that query vector and the document vector are orthogonal to each other and no match is found. If the cos theta value, as the cos theta value is ranging from 0 to 1, so for every set of query vector and document vector we can get a ranked value of the queries, and depending on the rank we can give the required documents to correspond to the query. Now look at the slide where the cos theta angle and the vector value and the query vector and document vector are represented in the figure. There are two document vectors, that is d1 and d2, and a query vector is there in between the document vector d1 and d2. So the angle between document vector d2 and query vector q, the angle between them is theta. We actually calculate the cos theta value from here. If suppose the query is same, another document vector is there, that is d1, and the angle between document vector d1 and q is suppose alpha, we can calculate the cos alpha value. So now please understand that we may have single query, but to correspond to the query I am mapping the query with several documents, maybe d1, d2 and maybe more. So for a single query we can grade from the cosine value of the document vectors and grade them according to the relevance factor. So the deterministic factor of this scheme is the cosine value. In the classical vector space model, the term specific weights in the document vectors are products of local and global parameters. The model is known as term frequency and inverse document frequency model if we put them together as a weighting scheme. Instead of attempting to calculate whether a document is relevant or not relevant, vector space model ranks the documents according to the degree of similarity to the query. So the vector space model can rank documents partially according to the cosine value. Now we will understand the weighting scheme for the vector space model. Weighting scheme for the vector space model is very simple. That is a multiplication of term frequency and the inverse document frequency. Term frequency is the frequency of the term which is occurring in the documents. Very simple. Suppose one term has occurred in suppose 5 documents, so the term frequency of the term is 5. That is as simple as that. The weighting scheme is just a multiplication of the term frequency into the log value of the inverse document frequency. Term frequency of the term T in document D, it is a local parameter. Term frequency gives an idea how well the term describes the document or a set of documents. Inter-cluster dissimilarity is quantified by measuring the inverse of the frequency of a term among the documents in the collection. If the term Ki doesn't appear in the document Di, then the corresponding TF value or the term frequency value will be 0. So now I'll explain the inverse document frequency. And the inverse document frequency, which is a global parameter, is basically a fraction. That is the total fraction between total number of documents in the document set and the set of documents where the term has actually occurred. So inverse document frequency is calculated as log value of, at the numerator it is the total number of documents divided by, at the denominator, the set of documents where the term Ty is present. So after calculating this term frequency and inverse document frequency, the weighting scheme is calculated as a multiplicating factor between term frequency and inverse document frequency. Now I'll go to the example part of the total scheme because you may find it very cumbersome to understand by notationally or just I have just spoken about the scheme. You may find it hard to understand. So I have designed one example which can give you a comprehensive understanding of the total scheme. Okay, so look at the slide. Suppose I have 3 documents, document 1, document 2 and document 3. So document 1 is with the sentence suppose New Delhi News. Document 2 is with the sentence like New Delhi Post, and document 3 has 2 words, suppose Mumbai News. Okay, now first I will calculate the inverse document frequency of each term. So first the index term is new. If you can see the documents that if new has occurred in document 1 and document 2 and the total number of document is 3. So the inverse document frequency value for new will be log of 3 by 2 base 2, which is 0.584. The second index term is Delhi, and Delhi, this term has occurred in document 1 and document 2. So the value is log of 3 by 2 base 2. So the value is 0.584. The same is also with the news, because it has occurred twice. So the value of news is 0.584. Next one is post. Post has occurred only in document 2. So then at the denominator part of the function it will be 1. So the corresponding value will be 1.584. Then same is with Mumbai. Now after doing this calculation, I am creating the term document matrix. So the term document matrix you all know. For your understanding purpose, for this set of document I have created a term document matrix. So row wise it is the document ID, and column wise it is the index terms. So you can also do is like that. Suppose the terms may be along with the row, and the document IDs may be along the columns. So both will do. So the document, for the document 1, new, Delhi, news, these three terms occurred. So for the corresponding cell value it will be 1 and the rest will be 0. So likewise I am doing for the 3 documents. So now after creating the document, I am multiplying each cell value with the inverse document frequency value. So after multiplying these two, it becomes like this. That is, document 1 for the term new, it is 0.584. Document 2 for the term new, it is 0.584, and likewise. Now I am calculating the query value. Suppose my query is new news. Okay, so now I am calculating the TF-IDF value for the query. Now if I see the matrix that new this term has occurred twice in document 1 and document 2. So the corresponding value of new for the query will be 0.084. But for the news, this term has occurred once in the query, but in the original term document matrix, news has occurred twice. So I am taking the half of it. Okay, so the query TF-IDF calculation for the query is like this. Now I will calculate the length of each document. Now keep in mind that this length or the distance factor is only Euclidean distance. So the length of the document D1 on the document 1 is the square root of the each cell value, that is 0.584 to the power 2, 0.584 to the power 2, and 0.584 to the power 2. After summing these terms, I am doing the square root of it. So it becomes 1.0115. For the document D2 it is the same, 0.584 square plus 0.584 square and 1.584 square. So after doing the square root of it, it becomes 1.78638. So likewise I am doing for the document D3 and the query. Now we will calculate the similarity value for the query as well as for the document D1, D2 and D3. So for the calculation part of the similarity values, I just put the TF-IDF value for the query and as well as the document D1. I have put them parallelly so that you can understand where is the match between the values. Now if you just refer to the slide, you can see that for the first value of document 1, TF-IDF value of document 1, that is 0.84, is matched with the query 584. The second match is not there because the 0 value is there for the query. Again, for the third value is matched, that is with 5.584 and 0.292. So the cosine similarity value is just we just multiply them, that is 0.584 into 0.584 plus 0 plus 0.584 into 0.292 divided by the length of document D1 and the query, and it gives the result as 0.7746. It is the cosine similarity value or the cos theta value. Same I am doing it for document D2 and document D3. You just refer to the slide. You can see that the TF-IDF values for the document D2 and the query for the query, they are put parallelly. You just match the values upside down. Okay, if you just see the slide, then you can understand that first value of document D2, that is 584, is matched with the query value, that is 0.584. Second value is not matched because 0 is there for the query. For the third term also there is no match, and the rest there is no match. So the cosine similarity value is the multiplication between the first two terms of document D2 and query, that is 0.584 into 0.584 divided by length of document D2 and the query, that is 1.78638 into 0.6529, and it gives a cosine similarity value as 0.2924. Same is applicable for the document D3. So after getting the cosine similarity value, we can grade them according to the value of cos theta or the cosine value. So the cosine value is the highest for the document D1, next is document D2, and next is document D3. So we can understand that from this scheme we can partially match or partial ranking system to the documents in accordance with the relevance to the query. So that is the greatest advantage of vector space model, and this particular gradation factor was not present in Boolean retrieval form. Okay, so I think that you have understood this particular method with the example. Now I will just explain what are the advantages and disadvantages of vector space model. The advantage of vector space model is that it is very simple, based on linear algebra. Term weights are not binary. It allows computing a continuous degree of similarity between queries and documents. It allows ranking documents according to the possible relevances, and it allows partial matching. That is very important. The major disadvantage of vector space model are long documents are poorly represented because they have poor similarity values. That means that a small scalar product and a large dimensionality, that creates a great problem. Such keyword must precisely match document terms. That is, the word substring might result in false positive match. The third problem is semantic sensitivity. Documents with similar context but different term vocabulary won't be associated, which also results in a false negative match. The order in which the terms appear in the document is lost in the vector space representation, because vector space model is basically a bag of words approach. Theoretically, it assumes that all the terms are statistically independent. And the next disadvantage is the weighting scheme is very intuitive, but it is not formal. It creates a problem while ranking the documents for a big corpus. So that was the end of the vector space model. Now I will move towards the next model, that is called the binary independence model. So this model was invented in 1976 by Robertson and Jones under the probabilistic framework. So to understand this model, the students need a prior knowledge on probability and conditional probability or the Bayes theorem, and these two concepts are necessary to understand this. Probabilistic model is based on the probability of predicting the relevant documents and remove the non-relevant documents. Suppose an user has given a query. So the query is parsed and that is to be matched with the stored documents. Now to answer the particular query, there will be relevant document. So let us say that that is the ideal set of documents or the ideal answer set, and other documents are not relevant, so that is to be removed out. The probability framework or the probability of predicting the answer in the real or the ideal answer set is always preferred. So that we do in binary independence model. So the assumption is very clear, that is, we assume that corresponding to a query, some set of documents will be there which are relevant and some documents will not be there, that is non-relevant. So the relevant documents are represented as capital R and non-relevant documents are represented as R bar or R naught. So that is the basic assumption. Now to understand the binary independence model, we have to understand first the probability rank principle. So if we cannot understand probability rank principle, we cannot understand binary independence model. So let us start with probability rank principle. Probability rank principle for a document D and a query Q. Suppose a random variable R is there to say whether the document retrieved given to a query is relevant or not. It can be defined as probability of R is equal to 1 given to document D and query Q, which is actually the basis of PRP. Risbergen in 1979 stated that if a reference retrieval system's response to each request is a ranking of the documents in the collection in order of decreasing probability of relevance to the user who submitted the request, where the probability are estimated as accurately as possible on the basis of whatever data have been made available to the system for this purpose. The overall effectiveness of the system to its user will be the best that is obtainable on the basis of this data. So the binary situation is incurred upon the ranking of documents in decreasing order after the probability calculation. So the document D is relevant if probability of R is equal to 1 given to D and Q. If irrelevant, probability that is R is equal to 0 given to D comma Q. So that is the 1-0 case of probability rank principle. The scheme is very simple. The random variable R will take the value 1 if the document is relevant, or it will take the value 0 if the document is not relevant. That is the 1 or 0 case of PRP. That is just only hit or miss type. Here the cost is just binary type because the value is only 1 or 0. The second case of probability rank principle is incurring the cost to the level of relevancy. So that is the second case. It is assumed that to incur cost upon the judgment of relevancy of the retrieved document. Let us assume that the cost C1 is to be given for not retrieving a document upon a query queue, and cost C0 is given to retrieval of non-relevant document. So according to the PRP, for a specified document D and for all not retrieved document D dash that is not yet retrieved is such as C0 into P probability R is equal to 0 given D minus C1 for probability R is equal to 1 given D, which is less than C0 into probability R is equal to 0 given D dash minus C1 into probability R is equal to 1 given D dash. So you should not intermix D and D dash. D is the set of relevant document and D dash is the set of non-relevant documents. So basically D is the next document to be retrieved. The main advantage of this method is that it can model differential costs of false positive and false negative and related system performance issues along with the validation of fault tolerance level at the modeling stage itself. That is the main advantage of probability rank principle. That's why binary independence model is based on probability rank principle. Here binary means it has the same meaning with the Boolean expression, that is 1 and 0. Documents and queries are represented as binary term incidence vector. A document D is presented as a vector form, that is X vector, which is consisted of x1, x2, x3, x4 up to xt. Suppose t number of terms are there. So x t is equal to 1 if the term t is present in the document, xt is equal to 0 if the term is not present in the document. So the model name is binary independence model. Independence means the term labeled here is occurring independently within the whole documents. So with this notation, many documents might have the same vector value representation. The probability function of PRP, that is probability rank principle, that is probability of R given DQ is relevant here but with a modified version. In binary independence model, Q is represented as incidence vector. So the probability function of P, that is R given dq, is transformed into probability R given xq. X is basically the term in the document. So we are just replacing the D with X. So using the Bayes theorem, it is when it is the case of relevant document, that is probability of R is equal to 1 given X and Q. So this is the expression, you can refer to the slide. And for the non-relevant case, P probability, that is R is equal to 0 given xq, that is the form. Now here probability R is equal to 1 given xq and probability R is equal to 0 xq are the probability of relevant and non-relevant documents respectively. So we must remember that if we just sum these previous terms, that will result to 1 only. So that is obvious and implied. From the probability theory, that is there. So the main advantage of this scheme is calculation is very simple and binary decision is easy to understand. Second advantage is inclusion of probability refines decision and increases the chance to retrieve true positive documents. The disadvantages of this scheme is the probability of relevancy and non-relevancy for the documents is not known beforehand. So the calculation of this probability are basically an estimation process, because it is under the assumption that it cannot explicitly compute the probabilities of relevance at the starting point of the scheme. It is assumed that after giving multiple queries, the whole system will try to stabilize, to understand or to indicate the ideal answer set only. So at the first hand, it is basically a estimation process. Second disadvantage is, as a vector representation of many documents are same, it also increases the chance of retrieving false negative documents as well as near duplicated documents also. So now I'll summarize the idea being represented in this chapter. Boolean logic or the Boolean expression for the information retrieval is based on the set theory. Vector space model is completely an algebraic model, and binary independence model is based on the framework of probability. So considering the intention and objective, I have concentrated only the foundational concept of these models, because unless we can't understand these three models, we cannot understand the advanced retrieval methods. All those methods are based on these three foundational concepts. Now, it is intended that the student will try to understand these three models so that the understanding on the total subject is complete. So at the conclusion part, I'll say that modern day search engines are incorporating very complex and sophisticated searching mechanisms, ranking functions, so that they can facilitate a good information service in a very packaged form to the user, so that it will be understandable, more palatable for the users. So there are many open source softwares, they also give the searching facility, but at the background this kind of model is being implemented. So thank you to all the students for your patience and listening to me. If you want to study more, if you want to know more, you can go to the reference part of my slide. From there you can get other learning resources to quench your thirst on this subject. Thank you all.